Okay, hello, this is Mr. Bing and Project Lead the Way Engineering, second course, Principles of Engineering. We're looking at assignment, is it 2.3.1? Yes, 2.3.1, and I'm going to try to do problem number 5 right now. And I'm hoping that if you are viewing this on Zoom, that you can see both my screen with the number 5, a 30-foot long solid steel rod is subject to. And then also I'm hoping you can see my little screen, which is my pen on paper. And when I get a little bit more information on the paper, then I will switch it so that, I don't know, maybe you can view it full screen already. I don't know if you what options you have when you view. I've made it for myself to have a little screen for me to write on. And so this is, let me see here. This is POE, right? POE. Is it two? What is it? 2.3.1. And this is problem number 5. Okay. So it says a 35-foot long solid steel rod. Okay, I'm going to write that down. L, I draw a little cursive L so that it doesn't look like a 1. L is 35, does it say 35 feet? 35 feet, okay, 35 feet, is subject to a load. Usually, it's just a force. Usually it's an F for force, but for some reason, I'm getting the vibe it should be P. And no particular reason that it's a P, but I know the P appears in some of the equations from the assignment. So I'm just going to make a guess. I'm just feeling like a P. 8,000 pounds. 8,000 pounds. This load causes the rod to stretch. Okay, I don't know what the variable for stretch is. I'll look that up in a moment. But I do know that a number 0.266 inches is a value that I can write down for that unknown variable. I get the feeling I do know. I'm going to make a guess. 0.266 inches. It says this caused the rod to stretch. I think is it deflection? Is it deformation? I'm going to make a guess, and I'm going to think this is a 50-50. This is a lowercase delta. That's a lowercase delta. I don't know how well you can see that. That could be the wrong variable. The modulus of elasticity, which again, I'm making another guess, is E. I'm having these memories flashing of what these variables should be, but I could be wrong. The modulus of elasticity is 30 million. 30 million. I don't know if you want to write the number 30 million, or if you want to write 3 times 10. Let me see, 1, 2, 3, 4, 5, 6, 7. 3 times 10 to the 7th. Is that 30 million? I don't know which one you want to write. They gave us 30 million, so maybe I should just write 30 million. The unit is PSI, which is pounds per square inch. And then it says determine the diameter of the rod. Now that's probably going to be lowercase d equals question mark. Okay, so far so good. That's the given and the unknown. If I understand the problem, which I'm not 100% sure I do, but I do know that I need an equation. That's the given and the unknown. Now I need an equation because that's how you spell guess. The equation, I need an equation. Here's some equations. I need an equation that gives me the value of d diameter as a function of L, which is length, P, which is a force, I guess, and then delta. If I'm right about delta in the problem, it says that it stretches. Delta is the total deformation or elongation. I think that's correct. I think that's delta. I don't know what you can see as far as my cursor. Yes, I feel comfortable with that. P, they don't say P, but I said P. I mean, a force, I can change it to F. Do you want me to? I'm going to change it to F. I don't know why I thought it was P. That's going to be F. F equals 8,000 pounds. And then the modulus of elasticity is E. I was right about that. Diameter is E, obviously. And then they use a capital L. I use a lowercase l, but let's just be consistent so not to confuse people. Okay, that's L. Okay, now I'm trying to find an equation that has a diameter in it as a function of L, F, delta, or E. L, F, delta, or E. L, F, delta, or E. Delta. Oh yeah, little delta. Okay, I see an equation. I don't know if you can see this. I see an equation. This equation, delta, that's a delta, equals force, we're given, length we're given, A we're not given, but we can find, or actually we need to find, and then E's elasticity. Well, you might say, well, the variable D does not appear in that equation at all. However, area is a function of D. In other words, we can use the area to sort of back calculate into what the D value is. So what I'm going to do in that case is I'm going to put that the A equals question mark is going to end up giving us that D value. And then before I switch my work here to the big screen, I'm going to write down delta, that's a delta, a lowercase delta, equals F times L divided by A times E. All right, now watch this, everyone. Maybe. Okay. Oh, I'm going to stop share. That's what I'm going to do. Nothing happened. I'm going to stop the share. Okay, is that good, Mr. Bing? Let me make that go away. Okay, can you still see? Oh, no, you do that for yourself. You can make that go away for yourself. There. I guess I'm just going to move that over there out of the way. Okay, so here is the paperwork that I have so far. And I'm trying to find the D value. However, it's a function of the A value. So if I find the A value, then I'm going to be good to back calculate. So looking at this equation, the algebra tells me that I need to isolate the A. And since the A is in the denominator, I need to move it into the numerator on the other side of the equal sign. So I'm going to do that. So it's going to be A times delta equals F times L over E. Please tell me if I'm making a mistake. And then I could have moved the A to the delta and then move the delta down into the denominator of the other side, but I forgot to do that in one step. I could have done just a switch of delta and A, but I forgot to do that. So now I'm going to have to divide both sides by delta to get A equals F times L times delta E. Does that make any sense, what the algebra that I've done there? And so now it's substitution time. A equals F is 8,000. And then the L value is, no, that's a problem. 35 feet. Why is 35 feet? It has to be in inches. So rather than calculate that for myself, because I'm too lazy, I'll have Siri calculate it for me. I'm just going to put 35. And what Nathan just said is it's got to be converted to inches. So you just multiply number of feet by 12 and you'll get the inches there. Does that make sense? How I'm doing sort of a lazy shortcut there. And then the delta, let me see, what's the delta value? 0.266. And then the E value is 30 million. I'm going to write 30 million, even though most people would write 3 times 10 to the 7th. I'm just going to write it as much as it's given, or as close to what is given. Okay, now it's Siri time. Let me try this. Hey Siri, what is 8,000 times 35 times 12? Okay, she said, I don't know if you could hear her on the video. She said 3,360,000. That's just the top part. Hey Siri, what is 0.266 times 30 million? Okay, I don't know if you could hear her. She said 7,980,000. Hey Siri, what is 3,360,000 divided by 7,980,000? .421 is what she said. And so let me move this up a little bit. 0.421. I don't know if it's right. There could be a mathematical error, but the concept is good, I feel. And this is inches squared. That's inches squared. Well, remember, we weren't asked for area. We found area because we knew it was a function of diameter. So diameter is what we really want. It would be nice, and I don't think the equation is given in the assignment. It would be nice if we knew the equation that relates area to distance. Or to diameter. Diameter implies that it has to be a circular piece. So the area of a circle, please correct me, pi r squared. Well, unfortunately, I said that area is a function of diameter, but actually area is a function of radius. However, radius and diameter are very, very closely related, and I'm sure we're going to be able to figure that out. I'm going to now do the algebra first before I start substituting numbers. So I want r squared by itself, r squared equals, and so I'm going to divide by pi to get rid of it. So this is going to be a divided by pi. Please watch me, make sure I don't make mistakes, which, as you know, I do that pretty frequently. So r squared equals the area, which we just found, 421, divided by 3.14. Okay, hey Siri, what is 0.421 divided by 3.14? Okay, she said 0.1305. Well, that's great, except guess what? That's not radius. It's still not radius. We don't even want radius, we want diameter. Well, that's the radius squared. So now we got to take that number. Hey Siri, what is the square root of 0.1305? Okay, she said a bunch of numbers there. I'm just going to put 0.361. She said 0.36124.8 ... which means it goes on and on and on. I'm just going to take that R value as 0.361, rounding off a little bit. 3 digits is usually enough. I don't really follow significant digit rules like I probably should, or I would if I was teaching physics upstairs. But I'm comfortable with that. 0.361, 3 digits. They gave us 3 digits here, so 3 digits there is probably good. However, that's still not what we're looking for. We found the area so that we could find the diameter, but it only gave us the radius. You know the relationship for diameter, don't you? Hey Siri, what is 0.361 times 2? 0.722. I don't know if you can see that. 0.722. The unit of the diameter was inches. I like to draw up boxes around my answers, and I think that's right. Do you guys trust what I just did as far as, does it seem to make sense? I'm not asking if it makes like perfect sense, but does some of what we did that makes sense? And another thing, what I would like to know from you is it more valuable to watch the process of me doing it and taking 25 minutes to do it, or would you rather just boom, have that picture for you to just look at and see if you can get the same thing? What do you prefer, Matt? The 25-minute video, okay. That's good. That's good. So I'm gonna stop the video now, or I'm gonna stop recording, and I just say, I gotta say bye-bye. Oh, wait a minute. Bye-bye.